Today I'm going to discuss with you what we call the universal gravitational force that is talked about by Newton, or what Newton talked about. He talked about a law which is in the universe, whereby for any two bodies that are in the universe, if there is a body in the universe anywhere, and these bodies maybe, if they are two, if you consider two bodies, then these bodies have what we call a force of attraction. That force of attraction is what we are going to call the Newton's, or what we are going to call the Newton's force of attraction for terrestrial bodies in the universe. Now, this force, he talked about it depending on the following. One, he said the force is directly proportional to the product of the two masses of the bodies. So one body can have a mass capital M, that is a bigger body, for example. Then a smaller body may have a mass small m. Then he also talked about this force being inverse proportional to the square of the distance apart between these two bodies. Now, when he merged these two relationships, he came up with a force which is going to be related with a formula. F is equal to capital G, capital M, small m, out of the radius squared, which radius is the distance between the two bodies. So according to Newton, G is what we call the universal gravitational constant. And this universal gravitational constant is a value which is approximately 6.67 times 10 to the power negative 11. And these are newtons, meters squared per kilogram squared. These units can be derived by making capital G the subject, then you use dimensions of physical quantities, and then you can deduce the SI units. So G is the universal gravitational constant, which is on everybody. It acts on everybody you know in the universe. Let it be me, let it be you, let it be the camera, let it be the earth, let it be the moon, let it be the sun, and so many more. Now, this force of attraction is everywhere. Even if you are two people close to each other or seeing each other, you have that force. You get the force attracting you to him and the force attracting him to you. That force is the same, which we call the force of attraction. And that force depends on what we call Newton's law of gravitation. Now, for example, if you have a big body here of mass capital M and another smaller body here of mass small m, this body has a force of attraction towards small m, and likewise small m has a force of attraction. Which force of attraction is this one we have just talked about? So according to Newton, this force exists everywhere. So if you consider, for example, two people, one man 1, has a mass of 100 kgs, and another man 2, has a mass of, say, 80 kgs. These two people can get into, or can be attracted to each other by the same force. According to this force, you realize that F, or the force of attraction between these two gentlemen, is capital MM out of small r squared. And r is the distance of separation between the two bodies. Distance between the bodies. Now, if these two masses have those distances, and I assume, because they are human beings, we can assume these human beings have a distance of 1 meter between them, then the force of attraction between them is going to be here as 6.67 exponent negative 11 times 100 times 80 divided by 1 meter squared. When you compute this force, you're going to realize that it's a very small value. So this force is a very small value, which is approximately 53.36. This 0 and this 0 and this 0, they are 3. We reduce 3 zeros from here, times 10 to the power negative 8. So in actual sense, it will be 5.336 exponent negative 7 newtons. If you write it in terms of decimals, you'll have 0.0000001, 2, 3, 4, 5, 6, 7, 336 newtons. So it's quite a very, very small force. Now, the reason why this force is very small is the same reason why people don't notice this force. You be there, you ask yourself, they're telling us, Newton says we have two forces of attraction between me and my parent. I see my parent, but I'm not seeing the way I'm getting attracted to my parent. It's because the force between you and your parent is very, very small. But this force can be witnessed on big terrestrial bodies, on the big satellite bodies we have in space, on the big moons we have, on the big planets. For example, the Earth can be seen to be attracted to the sun forever and ever. Reason being, the force of attraction between the Earth and the sun is quite bigger than the force between a human and a human. Reason being, the sun has a very big mass. The mass of the sun is approximately 2.0 exponent what? 31. Exponent 30 kgs. Then the mass of the Earth is approximately 6.0 exponent 24 kgs. So it means that because those two masses are very big, they will counterbalance off this exponent, negative 11, making it become now a bigger force of attraction for those two terrestrial bodies. That's why for the moon, for the Earth, for the sun, this force can be recognized. And that is the reason why the moon is able to be controlled by the Earth, because there's a very big force of attraction between the Earth and the moon. The Earth can be controlled by the sun. It's because the sun has a very big force of attraction, which is giving to the what? To the Earth. So the Earth cannot run away. The Earth has to maintain that circular orbit around the sun because of Newton's law of attraction, law of gravitational attraction, which is actually stating that, if you want to state it in English without using the mathematical expressions, it states that the force of attraction between two masses or between two bodies in space or in the universe is directly proportional to their product of their masses and inversely proportional to the square of their mean distance apart. So for these ones, at least for those bigger bodies, their force is quite big enough that we can be able to recognize it, and those are the reasons why we are bound to the sun as the Earth. That's the reason why the moon is bound to the Earth. It can never be away from the Earth. The Earth has to control it because of this force of attraction between the two bodies. So with that, I was trying to illustrate to you what Newton's law of gravitation actually talks about. Thank you so much. You can always experience some of these forces. Check it out. See the different terrestrial bodies you see in space, the different stars. They also have different bodies that control them. Likewise, those stars also control other planets. So with that, you can go ahead and read more about Newton's law of gravitation, see how this relationship can be used, also try to find out how much all this can be of relevancy to us as humans, to us as people who live on the Earth, to us as people who stay in this universe. Once again, thank you so much for supporting the channel. Keep liking the channel, share the videos, and don't forget to subscribe. Have a good time.